When you are asked on the spot to think of a scientist, most of us would immediately think of Albert Einstein. We can see Einstein on quotations, social media posts, and even on memes. Yet ironically, even though we know Einstein, not all of us know what his contributions to science were. So what were Einstein's discoveries that made him one of the most renowned scientists in history? Well, as a head start, Einstein basically held the existing physics of his time, such as Newton's Newtonian physics and Maxwell's electromagnetism, and flipped it over. What's up guys? Today in this video we will talk about why Einstein is my favorite scientist. To start, when I was young, I really loved the movie Meet the Robinsons, where the MC, Lewis, was a brilliant inventor who even made time machines. After watching that movie, the concept of time travel had really piqued my interest since then. Because as we all know, traveling through time is not possible since time only moves forward at the same time for everyone. But Einstein proved that wrong. In his theory of special relativity, he had published that the faster we move through space near the speed of light, the slower we move through time. For starters, let's start with Einstein's train scenario. Let's suppose that a train is moving at a speed near the speed of light, which is about 299 million meters per second, and that you have an observer standing on a railway embankment as a train goes roaring by. Then, each end of the train is struck by a lightning bolt just as the train's midpoint is passing. And because the lightning strikes are the same distance from the observer, their light reaches his eye at the same instant. So the observer correctly says that the lightning strikes happen simultaneously. Meanwhile, we have another observer that's riding in the middle of the train. From the second observer's perspective, the light from the two strikes also has to travel equal distances, and he will likewise measure the speed of light to be the same in either direction. But because the train is moving at a speed near the speed of light, the light coming from the lightning in the rear has to travel farther to catch up, so it reaches him a few instants later than the lightning coming from the front. Since the light pulses arrived at different times, he can only conclude the strikes were not simultaneous, that the lightning strike in front actually happened first. To the first observer who was standing still, the lightning flashed at the same time, while to the second observer, the flashes of light were in different moments. How could the two of them experience the same event differently? Well, Einstein thought that this would be possible if only time was not absolute, because in this case, time is only a matter of perspective. Time is not the same for everyone. Einstein broke that traditional understanding of time as a constant entity and proved that time in fact is relative for different observers. Because from this train to lightning scenario, it's perfectly possible for an event to happen simultaneously from the perspective of one observer, yet happen at different times from the perspective of the other, and both observers will still be right. Thus, the faster we move in space at a speed near the speed of light, the slower we move through time. Hard to understand, right? That's why even though I've watched a lot of videos about this concept time after time, I still couldn't get a grasp of understanding. But in layman's scenario, let's imagine that instead of 299 million meters per second, the constant speed of light was 1,000 miles per hour, and nothing in the universe can go faster than that. Now imagine you are running 10 miles per hour with a flashlight in your hand. Then you turn on the flashlight and point it forward. When taking Newtonian physics into consideration, that would mean that the light would be traveling straight ahead at 1,010 miles per hour. Because just like how you are moving on a car at 60 kilometers per hour in a vacuum with no air resistance at all, and you would throw a ball forward with a speed of 5 kilometers per hour, then the ball will be 65 kilometers per hour. Because 60 kilometers per hour is already the ball's existing inertial speed from the car. But unlike the ball, the case for the speed of light is different because the speed of light won't be 1,010 miles per hour because 1,000 miles per hour is already its universal constant, since light itself cannot slow down or speed up. So in order for the speed of light to remain constant, something else must slow down or speed up. In the formula, speed is equals to distance over time. If speed becomes an absolute constant, then the distance or time itself must have adjusted in order for speed to remain constant. The case of time slowing down in order for the speed of light to remain constant is called time dilation, whereas when the distance covered is shortened in order for the speed of light to remain constant is called length contraction. Insane, right? Well, that's not all. Every study that Einstein has published has helped shape and revolutionize modern physics today. He even thought of a theory which encompasses a fourth dimension on which there is a fabric of space-time on where the universe lies, and that the fabric of space-time would curve the more mass an object has, and that this curvature of the fabric of space-time would what we call gravity. And the theories involved in his general theory of relativity on how the fabric of space-time behaves, contracts, and warps can even predict the existences of black holes, white holes, and wormholes. All of his theories are very amazing, and it's no wonder that Einstein is always acquainted with the word genius. Moving on, most people in the scientific community would then agree years after Einstein's death that he was very much ahead of his time, because even today, modern astronomers and theoretical physicists will still engage on Einstein's ideas in proving the possibilities of time travel, the existences of black holes, wormholes, and white holes in the fabrics of space-time, and even on the possibilities of the existences of higher dimensions. Insane, right? That is why most people will believe that looking up in space and on probing its astral bodies and occurrences might really give us the answer to our long-thought philosophical inquiry on how the universe actually works and behaves, and on what are the secrets of reality and existence. That's all, and thank you for watching, guys. I hope you have learned something in this video. Don't forget to stay inquisitive.